This video is going to be me going over the topic for quiz 1 review. Remember that you will not be allowed to use a calculator on this quiz, so all the numbers will remain below 100, and you will be tested on your ability to use properties of exponents, not your ability to use your calculator. The first question on the review is worth 2 points on the quiz. It is asking you to just rewrite any expression in radical form using a fraction exponent. So the way that this works is that the number inside the radical, so our radicand 2, becomes the base of an exponential term, and the exponent is the numerator. So since this is being raised to the 5th power, that's going to be the numerator of our power. And then the index is the denominator. So in this one, our denominator is 3 because the index is 3. The question is just asking us to write it in the other form. So that is the answer to this question. However, for number 3, it's using the same property, but I'm going to use properties of radicals and roots and exponents to simplify so that I just get a value for my answer. So one thing to think about is that if I have 64 raised to the 4/3 power, I want to think about it as a radical being around 64 of the base of my exponential expression, and then that's being raised to the 4th power after taking the 3rd root. And so if I have a cube root, I want to try to think about 64 as something to the 3rd power. And so knowing that ahead of time makes the problem a little bit faster. So knowing that if I take 4 to the 3rd power, that gives me 64 is kind of a shorter way to get the answer. Otherwise, what I would want to do is I would have to take 64 and figure out the prime factorization. So for 64, if I'm factoring that with prime numbers, I always start with 2. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And then 2 divided by 2 is 1. Remember that in this prime factorization, I know that I'm done when I get that value of 1 at the bottom. So notice that this is a cube root, so I'm looking for groups of 3. So that gives me one group of 3 2s times another group of 3 2s is another way that I could get a 4 as the cube root of 64. Okay, so 2 different methods, either knowing that 4 is the cube root of 64, or by doing a prime factorization and finding 2 groups of 3 2s that I multiply together to get 4. So then finally, I have to evaluate 4 to the 4th power. So that means that I'm really doing here 4 times 4 times 4 times 4. And so for this one, this number is a little bit large. And so I'm doing 4 times 4 is 16. 16 times 16 is going to be my answer. So if I don't have my calculator, 16 times 16, I'm going to multiply 6 times 6, which gives me 36. 6 times 1 is 6. 7, 8, 9. So I've got 96. And then now that I'm multiplying by tens, I'm going to add my placeholder. So 1 times 6 is 6. 1 times 1 is 1. And so this ends up being 6 plus 0 is 6. 9 plus 6 is 15, which means that 16 squared is going to be 256. So 64 to the 4/3 power is equivalent to 256. For question 5, we're solving the equation negative 2x to the 3rd power equals 128. So remember that as we're doing these problems, when I write my answer, the type of root that I take gives me rules for the type of answer I will get. So if this is being raised to an odd power, whatever sign the number is after I'm taking a root, that's what sign my answer is going to have. So if I end up with a negative number, my answer is negative. If I end up with a positive number, my answer is positive. For an even power, however, my answer, I will always have a positive number because I can't take the even root of a negative. I'll get an imaginary, and we didn't really work with imaginaries in this unit. However, my answer is always going to be plus or minus for that problem. So when we look at 6 on your own, notice that's a 4th power, so you should have a plus or minus. So this question's worth 4 points on your quiz, or the corresponding question is worth 4 points on your quiz. Remember that the big idea here is that we want to get the x cubed by itself. Okay, so our goal is to start by isolating this, and then we will use a root to solve for x. So I'm going to start by dividing by -2 because that's what's being multiplied by x cubed. So if I divide -2x cubed by -2, that gives me a positive x cubed. And then if I divide 128 by -2, that's going to give me a -64. Okay. So remember that strategically what I'm doing to find the answer is I'm taking the x cubed equals -64, and I'm using the reciprocal power of that 3, so the 1/3 power, which means that I'm taking the cube root of -64 raised to the 1st power in order to get x by itself. Okay, so when I'm solving this problem, I am identifying the cube root of -64. In that last problem, we already determined that 4 to the 3rd power makes 64, right? So 4 cubed is 64, so that means that -4 to the 3rd power must equal -64. Okay, so that means that our value for x is -4. Okay, so notice because this was to the 1st power, my answer is just -4. I don't have to do anything with it afterwards to multiply to get a resulting value. So again, for number 6, when you do that, notice that it's the 4th power. So whatever value you get in your root, your answer will be a plus or minus for that one. The same rules are going to apply here with our simplifying inside a radical. So I'm going to do 8 for this one, just so that we can discuss the plus or minus, since we didn't do that in the last one. So this question's worth 3 points. So remember that when I see my index, I'm doing kind of 2 separate things. So with the coefficient, I'm taking that number, in this case 48, and I'm going to find the prime factorization. And so 48 is even, so I can divide by 2. So 48 divided by 2 is 24. That's still even, so I'm going to keep trying with 2. And so that's 12. Still even. 12 divided by 2 is 6. 6 divided by 2 is 3, and then 3 is not divisible by 2, but 3 is prime, so I know that that's the last number in my prime factorization. So remember that the index tells us that we're looking for groups of 4 of the same number. So if I have 4 of the same number, those numbers can leave the radical as a single unit. So these guys are going to leave the radical, whereas whatever I have left over, that has to stay. Okay. So that means that inside my 4th root, I still have a 3. Okay, so I'm leaving some space for the m. When we discuss the m, we discussed kind of 2 different concepts. So the first day that we learned this, they were always perfect roots, and so everything came out of the radical, and we talked about to find the value, we're dividing the exponent on the variable by the index, and then that tells us how many of that variable can leave, right? So if I have n to the 5th, what I'm doing is let me rewrite that m. I'm taking the exponent on m, which is 5, and I'm dividing that by the 4. So rather than looking for a group of 4, a shortcut with division, with exponents is dividing. And so if I divide just my power, 5 divided by 4, 4 goes into 5 once, and it leaves us with a remainder of 1. Okay. And so what happens there is that my exponents on the m are those two values. So it went in once, so that means that I can take m to the first power out. Sorry, I should color code that. It's going to take m to the first power out. And then I was left with the remainder of 1. So that's going to leave an m to the first power in. Okay. So that's just a little bit faster of a way to get the value for a variable. Remember that we could do a prime factorization of a variable. A prime factorization of a variable literally means I'm going to write out that I have 5 m's, and I'm going to do the circling thing. So if I have 5 m's, I can circle one group, and so that one group can leave, and then I had 1 left, and so that 1 m has to stay. Okay. So either way I think about it, that means that our answer is going to be plus or minus, because this is an even index. So plus or minus 2m times the 4th root of 3m. In the next type of problem, which will be 4 points on the quiz, we are combining radicals and simplifying. And so we can only combine radicals if they have the same index and radicand. That doesn't mean that we're going to ignore things that don't have the same index and radicand or the same index. We're still going to simplify as we go, and then we're going to combine like terms only. So let's start by just simplifying the radicals. So for the first one, I had 2 times the square root of 27. So let's start by factoring 27. So 27 is 3 times 9, which is 3 times 3, which is 3 times 1. Since this is a square root, I'm only looking for 2 of the same number. And so my coefficient is already a 2, so I'm going to multiply that 2 by a 3 because I have a pair of 3's that can leave the radical. And then I have an extra 3 that was left over that's going to stay inside the radical. So instead of having to radical 27, I want to think about that as 2 times 3, which is 6, radical 3. Okay, so I simplified that first radical. Now I'm going to go ahead and do the same thing with the negative 2 cube root of 81. So the number 81 is also divisible by 3. 3 divided by 81. 81 divided by 3 is 27. And then we already know 27 is those 3 3's. So I'm going to divide it by 3 again, get 9. Divided by 3 again, get 3. Divided by 3 again, and get 1. And so this one already has a negative 2 out in front of the radical. This time the radical is a cube root, and so that tells us that we want to take out 3 of the same number instead. So we have 3 3's, and we're left with a single 3 on the inside. So that means that the 2 times the cube root of 81 is going to simplify to minus 2 times 3, which is 6 times the cube root of 3. And then our last term is plus 2 times the square root of 3. 3's prime, so we know that we can't simplify that anymore. So remember that we have to have the same index and the same radical, so radicand. So that means that the only two pieces that we can combine are the square roots. So that means that our answer is going to be 6 radical 3 plus 2 radical 3 means that we have 8 radical 3 minus 6 times the cube root of 3. So again, I had 6, I added 2, that means I have 8 now, and I can't combine the 6 cube root of 3 because that index value doesn't match. The next type of question is multiplying. When I'm multiplying, I want to distribute, and I can multiply together things that have radicals and multiply together things that don't. So I'm multiplying coefficients with coefficients, radicals with radicals, and then I want to combine like terms, kind of like I did in the previous problem. So this question will be worth, or the corresponding question will be worth 3 points on your quiz. So I can do this organizationally using a box or distributing. I'm going to just distribute and color code. And so if I have 4 radical x, and I'm going to distribute that, so 4 times the square root of x, since they both have coefficients and they both have radicals, I want to multiply 4 times 4, which gives me 16. And then under the radical, I can multiply x times x, which gives me x squared. So I'm going to go through and just multiply these things together, and then I'll simplify in the next step. I'm going to then multiply the 4 radical x times negative 5. So since there is no radical, I can only multiply the positive 4 times the negative 5 and get negative 20. The square root of x is just going to carry along with the answer. For the next pair of values, I'm going to distribute the positive 5 to that same binomial. So if I multiply positive 5 times positive 4 radical x, I still can just multiply 5 times 4, which is going to give me 20 radical x. And then in my last instance, I'm going to multiply 5 times negative 5, which is going to give me negative 25. So what I want to do with this problem now is see if I can simplify and combine like terms. So if I have 16 times the square root of x squared, the square root of x squared is just x. So this term is going to be 16x. Then I have 2 terms with square roots of x. So that means that these 2 terms are like terms, and we can combine them. However, when we do, we have negative 20x radical x plus 20 radical x. Those cancel to 0. And so all that we're left with is the minus 25. So our answer is going to be 16x minus 25. So what we could have noticed is that these 2 expressions were actually conjugates. So remember that conjugates are in the form a plus b times a minus b, and they result in something that creates a difference of 2 squares if they get multiplied out. So if I think about this, this is 4 radical x squared minus 5 squared, because in the original problem, a, the first term was 4 radical x, b, the second term in each was 5, and one was a plus, one was a minus. So I could have recognized that and used the shortcut, because we do use the shortcut in the next problem. So when I am trying to rationalize my denominator, which will be another 4-point question on your quiz, I'm using this property of conjugates to get my radical out of the denominator. So for the first problem, what I'm going to do here is take the conjugate of my denominator. So since my denominator is 3 minus the square root of 5, I'm going to multiply by 3 plus the square root of 5 in the numerator and the denominator. so that that radical in my denominator will disappear, similar to how I ended up without a radical in the problem 11. So the whole point of this is so that our denominator becomes this difference of squares. So for our denominator, we know right off the bat, because of our strategy, that that's going to be something squared minus something else squared, meaning it's going to be my a, which was 3, my first term, minus the square root of 5 inside there for b. So I already know that that's what this will multiply to based on the property of conjugates. For the numerator, though, I do have to distribute the 4 to get the term. So 4 times 3 is 12. So my numerator is going to start with 12. And then 4 times the square root of 5. They're different types of terms. So that is just going to become plus 4 radical 5. It's just a coefficient. And so if I simplify this, my numerator, one has a radical, one doesn't, so I can't do anything to combine those. However, my denominator, I still have to simplify. So 3 squared is 9, minus the square root of 5 squared is an inverse, so that comes out as just the radicand, which is 5. So what I have now is 12 plus 4 radical 5 over 9 minus 5 is 4. So what I want to check is if I can simplify. So I take each piece, each term in my numerator, and divide it by my denominator individually to see if I can reduce. So since my denominator is 4, I'm going to put 12 over 4 plus 4 radical 5 over 4. And notice that I can reduce by 4 for each of them. So 12 over 4 becomes 3 over 1. So my first term of my answer is 3. And then 4 over 4, I can divide both of those numbers by 4 and get 1. So I get 3 plus the square root of 5 as my answer.